Okay. Well, tēnā koutou, tēnā koutou katoa, nā mai haumai to this webinar on EasyPH and easy passive house design. I am going to start my presentation now. Okay, so yes, welcome everybody to this this webinar through FINS, and I'm so glad that you could all make the time to be here. Hopefully this will be as informative as possible for everybody. Welcome especially to our FINS members and our AFA members who are joining us from Australia. It's great to have you here. Today is going to be a two-part presentation. We're going to talk about EasyPH, which is the Passive House Institute's new tool, which is an alternative to PHPP. But we're also going to talk about how to make passive house design easier in a more general sense. And I spent a while toing and froing trying to decide whether it was better to do the EasyPH stuff first or to do the more general support and guidance stuff first. But I think because we've got some non-passive house designers in the audience, I'll start and quickly go through the passive house, the easy passive house design advice first, and then we'll finish with the demonstration of EasyPH. If you have any questions, please put them in the chat, and then at the end of the session, Nikki will go through and she'll pick out as many questions as we've got time for. And if you could unmute yourselves and ask a question, and that would be fantastic. I understand if you want to keep your camera off, but it does help me if I can see some faces. So if you're not feeling too shy, then put your camera on. Okay, so just a quick introduction of myself. So I have been with Sustainable Engineering now for just over a year. I am a building analyst and a passive house certifier and passive house designer. And before coming to Sustainable Engineering, I worked for myself, a company called Hiberna, for about 12 years as an architectural designer and passive house designer. What drew me to passive house in the first place was when I did a master's in sustainable architecture. So I came at it from the sustainability perspective, and that was back in 2022. And the Brits really weren't sure what to do with this thing called passive house at the time, but have since very, very much embraced it. So there's the sustainability side that appeals to me, but also I'm a real details person. I love detailing, and getting into the nitty-gritty of passive house really excites me. And lastly, I really feel the cold. So I really appreciate living in a passive house as I do, and also being able to guarantee people that they are going to get the same experience of living in a warm and healthy environment. So passive house can be quite challenging, and it has a reputation for being challenging, and it really can be. I think my most challenging projects would be my own house, which was my first one, which I think is most people's most challenging one, and just getting their heads around the fluctuations of the numbers and what it all means. And that was also the first straw bale passive house in New Zealand. And then the other one is the Luggett Hall, which was the first public building in New Zealand to be certified. And I think we've got one of the building contractors here from the Luggett Hall. So welcome and congratulations on your building. So yes, it can be very challenging. we at Sustainable Engineering, being designers and certifiers, we want to, and passive house enthusiasts, we want to make it as easy for people as possible. We want to really promote the uptake of passive house, and certainly making it as accessible as possible as part of that. Turns out that the Passive House Institute also want the same thing, which is why they've released EasyPH, the new tool, to try and make it easier for simpler projects. So yes, as a company, we've tried to pull together as many resources as we can for making the design and certification process easier and simpler. And I'm going to run through some of those, and I'm also going to talk about some other people's resources that I think are very useful. And after the presentation, Nikki will send out a copy of the PDF so that you've got all of these links as an ongoing resource. So first of all, for your clients, if they need a real introduction into passive house and why they might consider doing it, then we have a primer on our website that you can download for free. Probably the biggest resource for us in New Zealand at the moment is the High Performance Construction Details Handbook, which was a very large bit of work done by Brands and Fins and Sustainable Engineering a few years ago. And the idea was to put out some commonly used details in high performance buildings, along with performance data. So there's a vast number of construction methods in here, and also a vast number of standard details. So this one, for example, is a timber frame wall with an internal services cavity, and there's CO2 levels for each construction type as well. And then there's also, as I said, lots of standard details that have all been modeled in Thermal Bridge software. And you can use these values if you're using the same construction types in your buildings, which will save people a lot of time. So another thing that can take a bit of time in the process is to provide evidence for the thermal properties of the insulation that you're using. So we put together these thermal conductivity tables of all of the commonly used insulation materials in New Zealand. A lot of them all apply to Australia too. And so if you use the exact name that's in the database here, then you don't need to provide any other evidence, which is a bit of a time saver. One of the biggest things that trip people up, and it can be incredibly time consuming, like days or weeks, is chasing window manufacturers for data on their glazing and their frames. And so the way that we have tried to assist with this is to when we've verified data from a supplier, is to put them into our database. And then if you use any of those windows, then you don't need to provide any further evidence, which can be a real time saver. We've also got some resources on thermal bridges. There's some companies that have done some modelling with us and have released the data publicly. You'll find those on our website here. And then we've got a vast number of articles on the website, which, you know, lots of interesting information on there that seems of the things that we find seem to trip people up most often. And then there's this old study from ProClima, which is still very relevant, and there's an Australian version too. on air tightness and moisture management in New Zealand, in the New Zealand climate. That's still very relevant today as a beginner's guide to building science in New Zealand buildings. This is worth a watch if you've got 7 minutes. This is from a group of passive house designers at EMU Systems, and it's advice for designers from builders. And the 3 things that they want us to focus on is to work on simplicity, make the building as simple as possible, reduce your form factor, make it simple to insulate and to airtight, reduce the number of penetrations as far as possible. Again, let's try and set the builder up to win. And then windows, again, just get them in early, specify them early, and make sure that you've got the right data early. There's a vast amount of great information on the UK Passive House Trust website. I think my favourites would there's a guide on avoiding overheating. There's a good practice guide to air tightness, and there's making the case for heat recovery ventilation. So there's amongst many others. So I would recommend having a look there if you get a chance. And then finally, if you are a new passive house designer and you're struggling to get your head around PHPP and how to how to deal with all of the different aspects of passive house design, then we have set up a course which is designed to follow on from the Certified Passive House Designer course. So this is a lot more of a practical guide. It's called Passive House in Practice, and so we take you through our own process as passive house designers from the very start through to certification. And that's an on-demand online course. You can take that anytime, and there's 4 one-on-one coaching sessions to check in with you, see how you're doing. The idea is you take a project from start to finish throughout the project, and we'll hold your hand along the way. If you are getting a building certified, get in touch with us early. We have a huge amount of resources that we can give you to help not only with the certification but with the design. There's just a vast number of guides and resources in here, right through to signage for construction sites. So in summary, how to make passive house certification as easy as possible with or without EasyPH. So whether you're using a standard PHPP or whether you've decided to use EasyPH, go through all that content in the certification resources. It is well worth the time. It's a bit daunting because there is so much of it, but it's worth at least a skim. Use the details from the High Performance Construction Details Handbook. It's going to make your life so much easier if you don't have to model your thermal bridges. Use windows from the Sustainable Engineering database if you get the chance. And use the insulation from the thermal conductivity tables. And if your preferred suppliers aren't on those databases, really encourage them to get in contact with us and to get their data verified, because it will help them get more passive house projects too. Finally, build in a margin, please, because often we see projects coming in at 15.49 kilowatt hours per square meter per year, and that just makes the whole experience very, very stressful for the designer and for the certifier. So give yourself a little bit of a buffer. And if you do want a little bit of extra help, then consider the Passive House in Practice course. But more than anything, just keep it simple if you can. My experience is that it doesn't take much complexity at the start at concept design to feed through into high levels of complexity at the end and as you're detailing and as you're modeling. So do yourself a favor and keep it simple, and it will be less painful for you and cheaper for your clients. Okay, so we're going to jump into a demo of EasyPH now. And so how does it compare to the latest release of PHPP? So first of all, the biggest change is that there's only 8 sheets. And they are all linked to this one sheet called EasyPH. There are limitations to EasyPH. You can only use it for single family homes. You can use it for a maximum of 2, but they must share a ventilation system. So that would be 2 apartments next to each other, or a house with an attached granny flat, something like that. So it's the single ventilation unit that is the limiting factor. You can only use it for passive house classic or plus, or a low energy building. You can't use it for premium because the primary energy needs to be much more rigorously explored, and there isn't an EnerPHit version as yet. So the workflow is quite different. So on the left, we've got the original workflow of working through a PHPP, which is very iterative, and you go round in circles to a degree, and it's not completely logical where you start or where you end. With EasyPH, the workflow is it's on that one EasyPH sheet, and then the workflow is from top to bottom. And the EasyPH sheet will link you through to any of the other sheets that you need to use. Okay, so we like simplifications because that makes everyone's life easier. So some of the simplifications in EasyPH are the specific heat capacity. So that's the thermal mass. So you have just 3 options now for 3 different levels of thermal mass in your building. The ventilation inputs are much simpler. The final protocol worksheet, that's the ventilation commissioning sheet, has been integrated into EasyPH, so that's one less file to deal with. Kitchen range hoods have become very easy to enter. Summer ventilation has been vastly simplified, and that will save quite a bit of time. The air tightness inputs have been reduced, and heat pumps and domestic hot water are now so nice and easy, whereas before these could take a very long time. So yay, PHI, thank you for those. However, there are some things which aren't so intuitive from our point of view. So the treated floor area and volume inputs are quite different to the standard PHPP, and we found that to be quite frustrating, at least in the context of our normal workflow. Specific heat capacity comes up again. So although it's simplified and you've just got 3 options, that means that you don't have the ability to customize the level of thermal mass in your building, which can be it means that you're going to have to take a worse case scenario rather than using the actual situation in your building. And I'll explain that as we get into the demo. Ventilation rates. Again, I'll talk about that as we get into the EasyPH, but essentially there's very little guidance about what you should put in for ventilation rates in EasyPH, even less than in PHPP. And what that says to us is that we really need to be upskilling designers on understanding when and where you might want higher or lower extraction or supply rates. Okay, so, oops. I'm going to start with our standard workflow. So we would always start in Design PH in SketchUp. So this is my little demo building here. It's very simple. And I've got here in red, the thermal envelope. Excuse me a minute. Let's move that over there. I've got the self-shading of the building, the thermal envelope, and then I've got my TFA, my treated floor area. So now then I want to export that. So I'm going to use my Design PH dialog box to export it, which is here. Export. I'm going to choose geometry only here, which I've already done. So then I'm going to open up two files. I've got my EasyPH file. This is it here. This is our one EasyPH sheet. And then I'm going to import the data from Design PH into that file. And the process is complete. Finish. So I can check that that's worked just by going into areas. Yep, so now I've got some areas in my areas sheet. Got some windows in my windows sheet. I've got some shading factors in my shading sheet, so I'm good to go. Right. So where do we start? We start at the top. And then each of these we can expand as we get through them. So first of all, we're going to go into project settings. We're going to choose what standard we want here. And the passive house class, the number of dwellings, we're going to choose, this is our thermal mass drop down here. So we've just got a choice between lightweight, mixed, and heavyweight. So if I choose lightweight, if I go into verification, I can see that I've got 60 in my specific heat capacity there. If I go to mixed construction, it's 132. So we would recommend that if you had a timber frame building on a concrete slab, that your specific heat capacity would be 84. So that's between the two. So given that we can't do that with EasyPH, your choices are don't use EasyPH or choose one of the other ones, which is going to give you the more conservative option, which is likely to be the lightweight construction. And then I've already entered in the building location and the climate data there, which again is just drop downs. So then if we go into U values, it's just going to prompt us to go into the U values sheet now, which is exactly the same as PHPP. And this is where you would enter all of your construction assemblies. And this is where if I was using the thermal conductivity tables, then I would enter the exact name from the thermal conductivity table into my U value calculator here. So then I'm going to go back to EasyPH. Now treated floor area, this is where the fun begins. So this is quite different to PHPP. So I just zoom out, you can see that there's a number of calculations that we need to cover here. So we start here. And it's going to ask us for data room by room. So first of all, we need to assign a floor level. So we can call this ground, or we can call it whatever we want to here. And I've gone through and I have entered in all of the living spaces, and I've just assigned them to that floor level and the amount. So you do have the option to enter the width times length, but what I prefer to do is to go into my design pH, and if I turn off thermal envelope and the shading, if I highlight each area, you can see that SketchUp will read that area for me, and then I can just copy that in. So I wouldn't be able to enter a width or length for this shape because it's not rectangular. So that is the way that I would do it. So what I'm going to do is I've entered in all of the rooms except for the last one. So I'm just going to enter in the WC so that you can see what I'm doing. So I'm going to go into my SketchUp model, and I'm going to find the area for this one space here, which is 2 square meters exactly. Enter 2, and then that gives me my total TFA up there. So this is quite a nice simplification here. So the passive house designers will be aware that there are different factors that you have to apply to different types of TFA. And instead of having to know those, there's a drop down box for you. This being a dwelling, they're all going to be 100% TFA. So I can just enter the standard TFA factor of 1. It's going to do it automatically for me. Okay. So then this next box, so what it's trying to do is it's trying to take the TFA and to calculate your total volume for your blower door test automatically. Now that's going to work really nice and easily when you have a flat ceiling. But if you don't have a flat ceiling, then you can't override the volume directly. You have to use this factor here. So this building that we're using has no flat ceilings in it at all. So I'm just going to put the minimum height in. Oopsie, 2.39. And if I go back into my design pH model, I've drawn the volumes because I like to do that anyway, because that would be how I would have calculated my volume for PHPP. So each of these volumes, if I save them as a component, as a group, sorry, then it will tell me what that volume is, and it's 4.91. So now I know that this total volume for this space needs to be 4.91. So I'm going to use a tool in data, what if analysis. That's called goal seek. So I want to set that value to 4.91. So I'm going to enter 4.91 in here. And I want to do that by changing this cell here. And it's done that for me automatically. So it's calculated what that factor is for each of these spaces. Yeah, I think that's probably the easiest way to do that. But the important thing is that you've got an accurate volume in the green cells here. Moving along, it also wants to link the ventilation flow rates to these individual spaces. So this is also the commissioning sheet here. So when this system is installed, the usually the installer will come and do testing to demonstrate that the system has been commissioned as it has been designed. So this is what I mean about there's not much guidance about, you know, how much extract or how much supply you need for each space. You're going to have to decide that for yourself. In PHPP previously, there was at least a little bit of guidance. Yeah, so I've taken some of the flow rates that we would typically use. So 60 cubic meters an hour for the living room. A bathroom would be 20, and then a standalone toilet would be 20 also. And then you can see, and then I've just balanced the supply volumes with the extract volumes. And now I have a balanced situation here. And then it will calculate up here what the standard level of flow rate is, this being the maximum. And it'll tell me what the air change rate is. And that's above 0.3, so that is all good. All right, so now we've done the hardest part. We go back over. I'll close that one down. We're going to open up the next one, building elements. So this is just going to take us to the areas sheet here. So these are our areas from Design PH. I'm just going to quickly assign my pre-filled in assemblies. And as with PHPP, I'm aiming all the time to get rid of my errors. So I'm just going to put in some standard values here. Make those errors go away. And then that's done. Right, so thermal bridges. So first option, don't have any thermal bridges, or use the thermal bridges from the High Performance Construction Details Handbook or another thermal bridge catalog or atlas. And then you can just put those numbers in straight away. So it's going to take us down to the thermal bridge input. I'm going to just make one up here. And that's done. Windows, okay. So we're just going to work our way through. So this is going to take us to the components sheet, which I've already put in the products that I'll be using. I've got my window and door frames there and my glazing there. And then if I go to position and dimensions, that's going to take me to the window sheet, which has been populated from the Design PH import. I'm just going to choose a single frame type just to make that easier. And then it'll take us to shading. So again, that will have already been done if you've done the bulk of your work in Design PH. You can add, you know, if you have blinds, then you'll need to, or shutters, you'll need to add in that temperature factor, reduction factor Z, as you would in PHPP normally. Okay, so this is the equivalent of the ventilation sheet. You can see there's not a lot to it. So we're going to select the unit, which in this case is the Zender unit. It's inside the thermal envelope. And we just put in the lengths of our ducts here. I've already got in the standard duct widths and insulation thickness and the thermal conductivity. But then that is done. Now, if your client does want a direct kitchen extract, then this is all you need to do for EasyPH. So generally speaking, you'd be encouraging people to use a recirculation range hood, in which case you don't need to fill in anything else. But if you do have a direct extract ventilation, then all you need to do is to fill in these 3 cells. So is it an efficient hood? The definition of which is up there. Yes. Is it open for the pressurization test for the blower door test, or is it sealed? So it will factor in an air leakage allowance depending on whether you say yes or no. And is there an airtight exhaust air flap? Yes or no? Very easy. Okay, so the air change rate, this is, you'd fill that in for commissioning. This is around, this is your sum vent sheet, so the ventilation in summer. So first of all, we just need to choose whether the ventilation system has a summer bypass or not. Probably does. And then in terms of the window ventilation, we've just got these tick boxes here, rather than filling in the different window configurations and their heights above each other and the openable width and so on. All we need to do is to tell EasyPH, is night window ventilation possible? Yes or no? Is it all round, which means can you do that in at least every other room? Are there tilted windows on the ground floor? And then these other 2 are if you've got more than one story. Air tightness. All we have to do here is just put in the ACH, the air change rate of the blower door test. Okay, so cooling. If we had cooling in this building, then we would tick this box. And you've got an option to do a simplified calculation or the detailed one, which is essentially the old method. So yes, we definitely want to do the simplified version. Yes, please. What kind of unit is it? It's an air-to-air split unit. Is it an inverter type? Yes or no? Cooling type is most likely to be recirculation cooling. We just need to put in, so the rated nominal power, let's say it's 2. And then we just need to put in the seasonal energy efficiency ratio of the unit. Let's say it's 3. And then this is just imperial units here. And then that's done. And then there is also an option for dehumidification there. So there's a section for compact units. We're not using a compact unit in this example. So if there's a heat pump, you'd fill that in a very similar way to how you do it for the cooling unit. And then there's a separate table for your domestic hot water heat pump, which is very similar. So let's say that is 3 kilowatts. And then we've got a few options here. The seasonal coefficient of performance, we'll just say that's 3 as well. So what this is asking is it to is the seasonal coefficient of performance to 35 degrees or 55 degrees C. So that's depending on whether you're heating it for domestic hot water or for heating. So if we're using it for, if we've got the COP to 55 degrees, and we just leave that blank. No, this will make a lot of people happy. This is the domestic hot water distribution and storage sheet, condensed. So we just need to put in the number of stories, the number of tapping points, whether there's pipe work outside the thermal envelope. If there isn't, then we can skip all of that. Storage. So where's the cylinder? Is it inside, outside? Storage volume. And is there a solar hot water connection? So then for the heat losses, the standing losses, there's a few ways that we can enter this. We can either enter it via insulation thickness. So that's, how much insulation is on your cylinder, or we can enter its ERP class, or you can calculate and enter the actual heat loss rate as you would in PHPP. These ones are for if you have more than one story. So you'll see that there's some guidance here over to the right on the different types of distribution system for multi-story. But we don't need that. And then if we don't have any renewable energy, then we are done. So that took approximately half an hour. So it can be very, very fast. It's a logical workflow from top to bottom, which I really like. I'm sure I'll get used to the TFA inputs with time, but it's pretty user friendly. And this is obviously relying quite a lot on the fact that I've already got a working design pH model, which I think is vitally important to speeding things up and ending up with accurate inputs in your PHPP anyway. So that is EasyPH. So I'll just quickly go back to my presentation, because I did just want to say one more thing. So Passive House, I've found, is very much a team sport. Everybody has to be on the same page. It takes a huge amount of trust and good communication and commitment from the whole team, from the client through to the plumber's assistant. The communication of the intent has got to go all the way through. So striving for a really cohesive design team is absolutely essential. Basically, you don't want to be this guy. You don't want to be the guy who's just going to trample over everybody else to, make themselves look good and ruin the project, which doesn't make for a good outcome. So thank you very much for attending. We've got through that quite quickly, so we'll have plenty of time for questions, which is good. I do just want to let you know that we do have another webinar coming up in about a month's time on a free embodied carbon tool that we have created. We use it for all of our projects, and we're going to be releasing that for people to use. We still need a name for it, so any suggestions would be greatly appreciated. Okay. Have I still got everyone? Nikki, how are we for questions? Okay. Nigel, would you like to ask a question, please?
Kia ora koutou. I'm in a to be certified straw bale passive house in Christchurch coming up, fingers crossed.
Oh, fantastic.
So as a result, I instantly saw the HPCD and wondered whether the straw bale details in HPCD are useful in this context. Are they transferable, the figures out of there?
Yes, so we do have figures for straw bale in the High Performance Construction Details Handbook. We don't have any junction details for straw bale because the structure in straw bale buildings tends to vary a lot. So it's just the U value of the component that we've got in there. But yes, you can use that.
Thank you.
And straw is in our thermal conductivity tables as well.
Thank you.
Elron, do you want to ask your question?
Hi there, thanks, Jess. Yeah, just when you whizzed through the ventilation bit there, it looked like the only option in EasyPH was entering the flow rates per room, whereas in full PHPP it's doing the three calculations of the total volume of the building, or the extracts from different rooms, or the occupancy. So what if there's not? Is there any hidden guidance in EasyPH, or what's the kind of like?
Yeah,
so take a stab and wait till the certifier to correct you when you get it wrong, or?
Yes. So that is definitely a failing in the EasyPH, and I think it does really highlight that we need to be learning more about ventilation design, because there is now even less guidance than there was before, and before it was quite sketchy, as Elron said. It's would be the maximum flow rate of either the extract requirement, the supply requirement, or 0.3 air changes. So if I would still be bearing all of that in mind as I was putting in those figures, but the only check that EasyPH is doing is whether the overall air change rate is above 0.3. So I think in some ways it's a good thing, because it will prompt designers to really think about the numbers that they're putting into EasyPH, rather than just relying on what pops up, because we know that if, for instance, the actual occupancy is different to the default occupancy, then you might have very different outcomes in terms of or rather, you might have very different optimal ventilation rates. So I think that it's a good conversation starter for trying to get more information, more guidance out there for designing ventilation systems for passive house designers.
Yeah, don't rely on the software for the answer.
No. Yeah. So if you're not sure, get some advice. Certainly we in New Zealand, we've got some quite hands-on suppliers who are quite generous with their time. So that would be my starting point. Tom, do you want to ask your question?
Thanks, Jessica. That's really lovely overview. Look, I have wasted many hours on heat pumps and trying to.
You're not the only one.
And make it work, and left scratching my head with some of the values that PHPP in the component sheet or the output sheet gives, and I just I'm aware that finding a reasonable number for some of these SEERs and SCOPs, whatever they are, is sometimes challenging. So I'm just wondering if you could provide any advice around how we can best, as a community, come to some way of
Yes,
trying to think
absolutely,
about that.
absolutely. And so first thing to say is that this is a work in progress for us. We're delving into this quite far. So we're talking to Jürgen at PHI at the moment about heat pumps and why we're getting these differing results using different tools, and alongside many other problems, like there's not actually many heat pumps that are have data to that particular standard anyway. So, you know, is it then invalid to use that number? So one of the things that we have discovered is that PHPP will reduce the efficiency of the heat pump quite considerably if it's oversized, because it will assume that it will hit an on-off point at around about 50%. So if you're oversizing your heat pump by around 50%, which a lot of people do because they want to cover you know, unusual circumstances, then most of the time your heat pump could be running at a very inefficient rate, or at least according to PHPP. So that's one of the reasons why we're getting strange values. But for the moment with EasyPH, I would be using the rated COP in EasyPH and the rated nominal power.
Okay, sure. No, that makes sense. Yeah, great. And look, then my follow-up, because I've had a brief dive into EasyPH, and I, without reading any instructions, added some data other than through the EasyPH sheet. And I'm presuming with the way you presented it, that then makes it invalid as a certifiable EasyPH building.
Yes, because then you're essentially breaking the tool. So yeah. If there's other things, then I would use your standard PHPP. Or you can use a conservative assumption like with the thermal mass.
Oh, okay. All right. Yeah, no, I kind of wondered about that, whether we were strictly limited to the options in the drop down, because it's kind of tempting to jump in and change other things. Yeah.
Yes, for sure. But no, that would technically be breaking the file. So
okay.
Yeah.
Thank you.
Okay. The error message that comes up with the TFA section, is that just a bug? Also, I had a play and it is saying 2 error messages. However, I can't find the second one. Russo, do you want to elaborate on that question? Sorry, I should have let you.
Daniela is my name. So I saw it on your worksheet as well, just in the TFA section, and it comes up with that error message. Is that a bug in it, in the actual EasyPH? Because like Tom, I've had a play with it, had a look around, just because knowing PHPP, it's easier to jump through it, I think.
Yes. Okay, let's have a look. So that's a good kind of segue into the check sheet.
Mine is not showing the check sheet. That could help.
Yep. So if you go to unhide.
In the easy, is it the EasyPH? Okay. All right. We've find my other one. Check. Oh, perfect. All right. Okay, so it's not actually showing it as an error.
No. So my errors are, let's see. I just take out my cooling units, it's saying that there's insufficient cooling. So my numbers that I made up obviously didn't work. And then let's see, also PER.
They're actually the 2 errors that I'm getting, PER and HP. Funnily enough.
Oh yes, I skipped this actually. So thank you. So in heat generator type, this is kind of the PER sheet. So we've got again, you've got to split your heating and domestic hot water according to the heat generator type. So if I just quickly fill that in. then that should, thank you, that's good, I missed that. I can now go to check. Yeah, there's no errors now.
Perfect. I didn't realize the check. Okay, yeah, mine's changed too now that I fixed that. Awesome. Awesome. Yeah, no, it doesn't come automatically with the check tab on. So
does it not? Oh, that's interesting. So yeah, I guess also worth pointing out that it does also contain all of the standard worksheets from PHPP. So you can go into those and see what's going on under the hood, so to speak. But you certainly don't have to.
yeah. Awesome. Thank you.
No worries.
There's a question from Tom.
Oh, thank you. Tom, do you want to? Oh no, I think we did that one. The heat pumps.
No, I think it just came in on the end. Sorry, I'm just struggling to scroll through. Tom, did you have your message read?
Sorry, I'm not sure which one actually. I just responded to a comment. But I will ask a quick question whilst I've got a voice.
Go for it.
Which way around, because I'm aware of the Echo tool that New Zealand Greenbelt Building Council developed that you guys were heavily involved with, and EasyPH, which one came first? Which was the chicken and which was the egg? Or are they completely unrelated?
They're completely unrelated. So EasyPH is a PHI tool. Yeah. So yeah, and Echo is a New Zealand Green Building Council tool. Yes, you're right though, Joe. It's yeah. I guess that maybe shows that the simplifications are sort of universally what people would hope for if it's similar to the simplifications in Echo. Julie, do you want to? Oh no, sorry. Yeah, Julie, do you want to ask a question?
Yeah, I just noticed that you exported only the geometry from EasyPH. Was that only because you had previously exported the full kit and caboodle, or would you normally export just the geometry?
I would only ever export the geometry.
Okay.
What I'm trying to do is I'm trying to get a functional model in EasyPH as quickly as possible, export the geometry into PHPP or EasyPH, and then do the rest of the work in PHPP, which would be my template PHPP, which would have all of my constructions and everything already in it, all of my construction assembly. So I don't want to waste time putting that into my EasyPH model.
Okay, perfect. Thank you.
Guy? If you've got a voice.
Any accounting for wind zone? Guy, did you have more on that?
So what Guy means is in the original in PHPP you have an exposure factor, and that has been taken out of EasyPH. So no, there is no accounting for wind exposure.
Wellington.
Yeah, interesting. Hey, so I don't know what the assumption that they've made is there, whether it's an average or a conservative average or what, but yeah, interesting that that's gone. Any other questions, comments, anything that people would like me to go through again?
I just had one, the what if analysis thing that you did. Is that something, like I kind of followed how you did it, but is it sort of just in lieu of a manual calculation really for that, what you're trying to achieve there?
Yes. Yeah, I can go through it again if you like, but I use that quite often when I'm trying to optimize in PHPP, so that I get the optimal number straight away rather than iterating. So yeah, I just find it a super useful tool, and I thought that this would be a good opportunity to tell everyone about it.
Tom's asked if the ground sheet is used in EasyPH.
No, it's not there, or it's working in the background, but no, It's not accounted for at all. You don't have to put any data into it at all.
Can I ask one last question? Just because you
Please.
guys do so much in this space, have you compared side by side a fully built PHPP with EasyPH just to understand how good, indifferent the results are?
I believe, yes. Not with PHPP 10.6. So we've compared it to other like PHPP 9 files, but they're going to be different to PHPP 10 anyway, because of the difference in the climate files. So yeah, certainly they did come out reasonably different, but yeah, that would be something worthwhile doing, is to find a PHPP 10.6 file and then to just put all of the data into EasyPH and see how it came out. There will be differences because of the assumptions.
Just
Yeah,
picking up that
no,
ground
sure.
sheet
Okay.
question again. Oh, sorry. You still talking? You still going, Tom?
No.
I was just going to pick up on that ground sheet question, Jessica, is so if you put a concrete slab in the U value and you put it against ground, obviously it can make an assumption about what's going on. Do you think if you're doing a suspended timber floor, then you just put the U value against ambient air so that it doesn't assume it's on the ground, or still put it against the ground because it makes some adjustment to the fact that there's a crawl space, protected crawl space or something?
It would, yes. So it would depend on how high off the ground the building is. So beyond a certain point, the ground isn't going to have any effect at all. So you would set it to be to ambient air. But if it's like a standard crawl
Like half a meter
space,
kind of thing.
yeah, with you know, some sort of cladding around the outside, then you would still enter that to ground, and then then it would be allowing for those crawl space benefits.
Okay.
Julie, you've got a question about Windows?
Yeah, I just wondered if you still use the Windows sheet for that, you know, for the extra mullions. You know how you can enter the whole window as one and then do that thing. Do you still do that in EasyPH?
Yes, you can. So I didn't do that just for to keep things fast. So I had each individual sash drawn in Design PH and then exported it to EasyPH. So that's kind of like the PHPP 9 methodology. But if I just share quickly. I'm looking for Windows. Yep. So it would be in the components sheet. Well, both. So yes, you can use the sheets are exactly the same as in PHPP 10. So in the frames, you can enter fixed glazing and mullion frame data, and then in the Windows sheet, you would then enter the total size of the window rather than each sash, and then you would fill in the lengths of the fixed glazing and the mullion lengths and the transom lengths. So that's going to be more accurate for certification, because then you're not doubling up on frame widths. But yeah, if you use the PHPP 9 methodology, then that's a conservative assumption, because you're going to be losing more heat through that extra frame length that's built into that methodology, if that makes sense.
So it's okay to stick with the 9 method and just ignore that whole bit of the
Yeah. I mean, yeah, it's tricky because in when you start off your design, you probably want to be looking at individual mullions for for your shading analysis and so on, like we've drawn here. So each sash is drawn separately, but if you were to then use the PHPP 10 method, you would enter this window as, I'll get it to work. I would enter that window as one sash, and then I would break it down to into 2 sashes in PHPP using these lengths of mullions and so on. So yeah, it depends. I would probably start like this, and then if I was being really picky, then I would go through and I would change my windows to the 10 methodology for certification. But I don't believe you have to, but I'll check. Tom, you had a question?
Oh, sorry, more a comment. I kind of wondered, any thoughts you had on hot and humid climates, where that EasyPH dehumidification entry is fairly limited. Look, it's only probably just sort of starting to become more of a concern for designers in Australia up north. It's not something I've delved into too deeply, but I'm just aware.
Yes, for sure. And this is early days for us too. I think that would be a really good thing to explore, is to compare a standard PHPP with an EasyPH in a climate that requires dehumidification, and see what the difference was, just as a sanity check before moving on to always using EasyPH.
Yeah, no, for sure. Okay. So.
Okay. We have finished up a little bit early, so I will get Nikki to send everyone a copy of the presentation, so you've got links in there and so on. And I hope it was useful, and thank you very much for attending.
Thanks, everyone. Thanks,
Thanks,
Jessica.
Jessica.
That was wonderful. Bye, everyone.
Thank you. See you.
Bye.
Bye.